Electrical. The evaluation of the electrical supply and systems is fairly complicated because it covers so many areas. It also poses potential hazards to the home inspector and often highlights defects that could endanger the home's occupants. Please take InterNACHI's free online How to Perform Residential Electrical Inspections course and the free online Advanced Electrical Inspection Training course. Always keep safety in mind. Stay safe. Protect yourself and your clients by getting the proper training on electrical inspection and equip yourself with the appropriate safety gear. Please take InterNACHI's free online Safe Practices for the Home Inspector course. A home inspector is not required to remove the dead front cover from the electrical panel. It is fatally dangerous to do so. We do not recommend removing the front cover to view the distribution wiring or components inside the panel. It is not required by the InterNACHI Standards of Practice. According to the Standards of Practice, the inspector shall inspect the service drop, the overhead service conductors and attachment point, the service head, gooseneck, and drip loops, the service mast, service conduit and raceway, the electric meter and base, service entrance conductors, the main service disconnect, panel boards and overcurrent protection devices, circuit breakers and fuses, service grounding and bonding, a representative number of switches, lighting fixtures, and receptacles, including receptacles observed and deemed to be arc fault circuit interrupter or AFCI protected using the AFCI test button where possible, all ground fault circuit interrupter receptacles and circuit breakers observed and deemed to be GFCIs using a GFCI tester where possible, and for the presence of smoke and carbon monoxide detectors. These are the things the inspector shall inspect. Service. Service is a term used to describe the conductors and equipment for delivering electricity from the utility company to the wiring system of the building served. Only one is typically installed for a dwelling. A minimum of 100 amp service is needed for a single residence. The service entrance cable, SEC, is a line of service conductors located between the terminals of the service equipment, or main disconnect, and a point usually outside the building, clear of building walls, where they are joined by a tap or splice to the service drop or overhead service conductors. The service point is the point of connection between the facilities of the service utility and the premises wiring. The overhead service conductors are also the overhead conductors between the service point and the first point of connection to the service entrance conductor at the structure. The service equipment is the necessary equipment, usually consisting of circuit breakers or switches and fuses and their accessories connected to the load end of service conductors to a building or designated area and intended to constitute the main control and cutoff of the supply. It is understood that raceways, fittings, and enclosures housing service conductors are also part of the service equipment. Meter socket enclosures are not considered service equipment. Meter enclosures do not have interrupting ratings, disconnecting means, or overcurrent protection. Grounding and bonding. Generally speaking, the difference between grounding and bonding is grounding is a direct connection to the earth to aid in removing damaging, transient overvoltages due to lightning. The purpose of bonding is to ensure the electrical continuity of the fault current path to provide the capacity and ability to conduct safely any fault current likely to be imposed and to aid in the operation of the overcurrent protection device. Properly bonding all metal parts within an electrical system helps ensure a low impedance fault current path. The issue of grounding and bonding confuses many inspectors. Due to its complexity, we highly recommend taking the free online How to Perform Residential Electrical Inspections course. AFCI. AFCIs were developed in response to a need for equipment to sense where an arc fault was occurring. A combination type arc fault circuit interrupter should be installed to provide protection at all branch circuits that supply 120 volt single phase 15 and 20 ampere outlets installed in family rooms, dining rooms, living rooms, parlors, libraries, dens, bedrooms, sunrooms, recreation rooms, closets, hallways, and similar rooms or areas. GFCI. GFCIs are designed to sense any difference in current between the supply on the underground or hot conductor in a circuit and the grounded or neutral conductor. Since the early 1970s, GFCIs have been required in an increasing number of damp and wet locations, and more recently, this requirement has extended to all receptacles in garages. Because they are safety devices, the home inspector should check every installed GFCI circuit and may advise the client of areas where they should also be fitted. According to the standards of practice, the inspector shall describe the main service disconnect's amperage rating, if labeled, and the type of wiring observed. Most circuits in the modern North American home and light commercial construction are wired with non-metallic sheathed, or NM, cable designated type, often referred to by the brand name Romex. This type of cable is the least expensive for a given size and is appropriate for dry indoor applications. Many people use the name Romex when referring to type NM cable. Romex is a trademarked name that has come into common usage for referring to plastic-covered wires, but type NM just means non-metallic and also applies to other cable systems. Home inspectors are not code inspectors. Again, electrical inspections can be fairly complicated, especially in the case of older properties where there may be a variety of systems and wiring types, some of which would not meet current codes. However, home inspectors do not perform code inspections. They are only required to evaluate the condition of the systems and report observed deficiencies that pose a danger to the property or its occupants. Home inspectors should inspect the house without direct reference to the age of the house. For example, GFCIs and AFCIs were required by construction standards and residential code in various times in the past. Because a home inspector is not a code enforcement officer or code inspector, the home inspector need not be concerned with when the GFCI should have been installed or not in the house. If a home inspector observes a lack of GFCIs in the house, that is a defect that should be reported by the home inspector. Another example would be smoke detectors. Code requirements for smoke detectors have changed over the years. Years ago, only a few detectors were required in a house. Presently, there are many areas in the house that smoke detectors should exist, regardless of whether the home is newly built or 50 years old. Smoke detectors, just like GFCIs, save lives. Pay no attention to grandfathering excuses provided by homeowners, contractors, or real estate agents. Inspection process. It's ultimately up to the home inspector to develop their own inspection process. The initial steps of the inspection sometimes starts outside with an inspection of the service supply from the utility company's equipment. The inspection then may follow the attachment to the house structure, the service entrance cables, the electric meter, the main disconnect, and the connection to the main distribution panel. The objective for the home inspector is to check everything that is readily accessible and observable and to document indications of observed deficiencies in the components. Visual inspection of the service panel or panels may come next in the process. The home inspector is not required to remove the electrical panel's cover, called the dead front, from the accessible main panel and any sub-panels. If the inspector decides to exceed the standards of practice and removes the cover, the inspector might look at the condition of the panel, breakers or fuses, panel interior, and the attachment of branch circuit wiring and determine what the materials are that are used in the electrical system. In some cases, the inspector may find solid branch aluminum circuit wiring that may require further evaluation by a qualified electrician. You may find that there were renovations at the house and newer wiring installed by homeowners, which would result in a condition that may be unsafe. All electrical wiring should be conducted by an electrician and inspected to meet code requirements, and that is far beyond the scope of a home inspector. According to the standards of practice, The inspector shall report as in need of correction deficiencies in the integrity of the service entrance conductor's insulation, drip loop, and vertical clearances from grade and roofs, any unused circuit breaker panel opening that was not filled, the presence of solid conductor aluminum branch circuit wiring if readily visible, any tested receptacle in which power was not present, polarity was incorrect, the cover was not in place, the GFCI devices were not properly installed or did not operate properly, evidence of arcing or excessive heat, and where the receptacle was not grounded or was not secured to the wall, and the absence of smoke and or carbon monoxide detectors. These are the items the inspector shall report as in need of correction. Overhead wires. Overhead wires from the street should be higher than 10 feet above the ground, not in contact with tree branches or other obstacles, and not reachable from nearby windows or other accessible areas. The wires should be securely attached to the building and have drip loops where they enter the weatherhead. Wires should not be located over swimming pools. Aluminum. Solid conductor aluminum branch wire was installed in houses primarily during the 1960s and early 1970s and is a potential fire hazard. According to the U.S. Consumer Product Safety Commission, fires have been caused by the use of aluminum wiring in homes. According to the standards of practice, the inspector is not required to insert any tool, probe, or device into the main panel board, sub-panels, distribution panel boards, or electrical fixtures, operate electrical systems that are shut down, remove panel board cabinet covers or dead fronts, operate or reset overcurrent protection devices or overload devices, operate or test smoke or carbon monoxide detectors or alarms, inspect, operate, or test any security, fire alarm systems or components or other warning or signaling systems, measure or determine the amperage or voltage of the main service equipment if not visibly labeled, inspect ancillary wiring or remote control devices, activate any electrical systems or branch circuits that are not energized, inspect low voltage systems, electrical de-icing tapes, swimming pool wiring, or any time-controlled devices, verify the service ground, inspect private or emergency electrical supply sources including but not limited to generators, windmills, photovoltaic solar collectors, or battery or electrical storage facility. Inspect spark or lightning arresters. Inspect or test de-icing equipment. Conduct voltage drop calculations. Determine the accuracy of labeling, or inspect exterior lighting. Again, the inspector is not required to do any of those things. Some additional notes. In all cases, the electrical inspection is a visual one, and the inspector should not put themselves or the client in any danger while inspecting the house. To that end, the inspector is not required to insert any tools or measuring devices into electrical panels. Systems or circuits that are turned off at the time of inspection should not be re-energized, as they may have been shut down due to existing faults. Operating breakers, disconnects, or removing fuses is also not recommended, as this can disrupt operation of the homeowner's electronic devices, including clocks, alarm systems, or computer equipment. Low-voltage circuits need not be inspected and are excluded from the standards of practice. Such systems include alarm equipment, intercoms, some lighting circuits, doorbells, and irrigation systems. Similarly, lightning arresters, power generators, and any electrical storage devices are excluded from these standards, as are swimming pools and exterior spa systems. Some inspectors have received specialist training to evaluate these systems and charge accordingly. While the inspector should report obvious deficiencies in labeling of fuses and breakers, the inspector is not required to evaluate every circuit and its labeling for accuracy, nor is it possible to fully evaluate hidden systems, such as grounding rods and their continuity. It is also well beyond the scope of most inspections to give an opinion as to the adequacy of the systems to support future usage.